So that one's running. This one, I have yet to do anything to it. I need to do a compression test, check for spark, see what all it needs. These are the correct spark plugs, and they look good. Oh, brand new one. You're really supposed to hook the positive up first and then the negative, but the way this ski is positioned, it is impossible because of how far the battery goes up under there. So you do what you can. Okay, we should hear the display kick on when I hook this up. We do hear it. Okay, I'm going to turn it over and see. Very good. I'm going to put a little oil in the cylinders. And I'm going to turn it over a little bit to get that oil on the side walls. And I think I hear the fuel pump cutting on. The engine sounds good. Put the compression tester on it. Cylinder 1, or mag. Very good. 181, something like that. Cylinder 2, which would be PTO. Perfect. Almost identical. This is a healthy ski. Now on this ski, the crank position sensor is missing, so I'm going to rob it off of the blue ski to see if I can get spark. Now removing the water temp sensor. I don't think that is a reason that it wouldn't be firing, but it's missing this, so I'm gonna take it off of the blue ski, put it on the yellow in hopes of not having the code pop up on the display. Okay, this is the first glance at spark after I put those in. Still no spark. So we're going to work on process of elimination, and the first place we're going to look is the wires coming out of the stator, and they lead to the back of the EMM. I'll unplug that one. This is the end of the wires coming from the stator. This is where the computer gets all of its energy from the engine. And the battery is just to crank it and a few other things, but mainly power comes from this. So these two, they should have 7.5 volts AC. Then these two 7.5 volts AC between each, and then these are charging. And also you can run a resistance test on all of these from that one to that one, and it should have about 0.4, 0.3, 0.4, 0.5 ohms of resistance and on all of them. And then you can test with a positive lead on each one of these as you take the negative lead and put it on the ground somewhere, and make sure that none of them are grounded out. If they are, it's automatic bad. So I expect to get correct readings on all of these if the stator is in good condition. So I'm going to measure the first two. Measure the second two. Measure the third. Measure the fourth. And then measure the fifth. So what that tells us is something is not right with these two up here. So now we're going to do a crank test to confirm that hypothesis, I guess would be the term you would use. Now we're going to put those two together and crank. Okay, so there's a problem there. Okay, let's do these two. We should get, if these are working. They seem to test out good on the other ones that we tested. So let's try these two. Now that's good. That one tested good. And that one tested good. Tested good. That one tested good. And last one. Good. Okay, so what we know is these two, something is wrong. And fortunate for me, on the shelf, I have a good known direct injection stator. Okay, I took all the bolts out and I'm gonna try to crack it. So I have already taken the cover off, and I have a heavy duty flywheel puller, and it is hard to see. There we go. Heavy duty flywheel puller. It takes a lot of pull to get this flywheel off. It's on there with red Loctite from the factory, I think, and it needs to be put back on with that to keep from shearing the pin if the engine was to stop abruptly. But I have a pretty big wrench, real big wrench, on the PTO shaft, helping me to turn this. Okay, I'm going to test the new one before I put it in. Or I say new one, it's a used one out of another jet ski. And we should have somewhere around 0.5 to 0.8 ohms. And we have 0.6. That's good. Next one, 0.6. Third one, 0.5. That's good. Next one, 0.5. 0.4. Good. These bottom three are a little lower resistance than the top two. Is normal, 0.4. Good. So that is a known good stator. And while I have this cover off, I'm going to go ahead and take the Bendix out. And I'm just checking to make sure this thing operates properly. They seem to give trouble on old skis. It is working flawlessly, but I am going to put some grease on it just to make sure. What I'm trying to do is pack as much grease as I can. Once I get as much grease as I can in it, I'm going to clean all the grease off of it. I really don't want the outside to have a lot of grease on it. I do want that. I want that to have grease on it, because there's no bearing. It's a bushing instead of a bearing. That's working good. I'm going to get some machine oil down in there. Okay, I've got everything back together, and I'm going to see if we got spark. As I crank it, I'm going to turn the light away so we can see if we got spark. Nothing. So now that we know the stator is good, the next step in diagnosing a no spark on these direct injection skis is to check the voltage on the white and red wire going into anywhere that there's a red and white wire. It's all connected together. So we have to find out the voltage with everything plugged up. So I'm going to make a jumper wire, and we're just going to probe up into there. So what I'm going to do is just stick the end of the wire down in here, just like that, and then plug this back in. Okay, I'm going to put this right there so that can sit on that. Okay, I think that'll work. So let's see what kind of reading we get. We want direct current, and we want to see 21, at least 21 volts while cranking. And we got 24. So that is very good. That indicates that it may not be the EMM, the computer, that is causing our problems. Okay, I'm going to unplug the throttle position sensor now. So that little device is the throttle position sensor. It can cause a lot of problems, and it seems to be okay, but I'm going to unplug it and then see what happens. Still no spark. Now I'm going to check the crank position sensor. I'm going to ohm it, make sure it is okay. We should get between 100 and 150 ohms. 133. It's a little low, but it works. So I took the EMM bracket that's got a lot of stuff behind it loose, and checking out the capacitor. It's good, but I did notice that's unplugged. That might be our culprit. So I'm going to plug it back up and put a zip tie around it. It just don't look that secure. So I took the computer out of this one and I left the injectors in place, but I took the computer out and put it in this one. I just left the computer mounted because I didn't know if this was going to be the culprit or not. So hooked this computer up, and now we have spark. So that lets me know, unfortunately, that the culprit is the computer. So it is going to be sent off to Lakeside Tech and be rebuilt, or that one will. So what I'm going to do on these Polaris direct injection, the EMM computer, it's called the engine management module, is coated with the injectors. So the mag injector must stay with the mag cylinder. The PTO injector must stay with the PTO. They set the mapping coefficients to each cylinder that matches with the computer. So all of this has to remain as a set. So what I'm going to do is take the old EMM out, send it out to get repaired, take the two fuel injectors out, keep it with it, and I'm going to put these two injectors in the blue jet ski. And when I have this EMM repaired, it's going to go in the blue jet ski, and then I'll have 3 working skis, no doubt. These water lines are terrible to remove, so I always use a heat gun to heat them up to get them off. They have to have water lines because that computer gets so hot that it needs a water jacket inside of it to run lake water through it to cool it down. It's seen better days. And this connector is held in by Allen screw. That will allow us to get the O-rings out. I'm going to write on this PTO and mag. Okay, these go with the other injector. And here's the injectors that match this EMM. Okay. Good. Good. Okay. So, now we got to get fuel. I'm going to check it again. Good, have good spark. Hopefully this is the last time I have to install the plugs for a while. Okay, this is the first attempt at cranking. Put it gearing forward. Lanyards in. Here goes nothing. Hydrolock. Took the plugs back out. And that's why. Still puking a little bit of stuff out. Temps 15. It wants to. She wants to run. Close, close, close. Attempt 16, if I'm counting. I don't know how many it is. So close. Oh my goodness, it's close. Try 17. Attempt 18. Blew the cylinders back out and poured a little bit of fuel in each cylinder and a little bit of fuel in the intake manifold. Love the smoke. It is normal for them to do this. I may go one more time just to... So I thought I would narrate this last little section. It is running good, but it is so hilarious that I thought I would tell you about it. I crank it up and I could not get it to stop running. I'm hitting the start-stop button at the moment, and it's not stopping because the LR503 module is bad, which is the start-stop module. So I opened the hood thinking that I could unplug the display and then unplug the LR503 module to make it stop running. And all I would have had to have done is pull the lanyard. But in a panic, I don't even think about that. So I run to the back of the ski after attempting one more time and figure I would disconnect the battery. But like a fool, I don't realize the battery will not stop it from running. And so, after disconnecting the battery, I have the wise idea of pulling the plugs, which did work. Pulling the plugs worked, but what's weird is the thing ran good with one plug unplugged, or plug wire. And so I managed to get a rag in my hand, unplug the first one, still running, unplug the second one, and it finally shuts off. Hope you enjoyed the video. And the next one, I will be cleaning these two skis up and getting them on the water. Thank you so much for watching. not shut off. I gotta get a new start-stop module on it. It runs.